Hello everyone. In today's discussion, we are going to interact on the concept vector calculus. In vector calculus, I am eager to discuss on the concept called divergence. Divergence is a very important measure in vector calculus. So, as a definition of divergence, divergence is an vector calculus measure that measures the magnitude of a vector field, that is, it is measuring the magnitude of the vector field source strength at a particular given point. So, as an application of this divergence, we can apply it in fluid dynamics. In fluid dynamics, we can use this idea to understand the rate of expansion or contraction of fluid flow. So, it is very important in fluid dynamics to understand the rate of change, the rate at which the expansion or contraction of a fluid happens. So, in this scenario, we use the mathematical model representation. Vector calculus is very much beneficial as it has the concept of divergence as a measure. So, divergence of a vector field is given by the mathematical representation, where we use the del dot operator concept to find the measure of the strength, that is, we focus on the magnitude of the field. So, next in discussion about the properties of divergence, and to understand its definition, we know, as discussed, divergence measures the rate at which a vector field is expanding at a given point. So, in this scenario, as a property, so physical interpretation can be discussed. The physical interpretation represents the outward flux of a vector field from a infinitesimal volume around a point. So, the relation between sources and sinks can be understood even. So, divergence is positive at sources, negative at sinks, and 0 where the field neither diverges nor converges. These are some of the properties, beneficial properties of divergence. Further on discussion, let us talk more on divergence of vector field. So, divergence, you all know, it is a vector field and it represents, it measures the magnitude of the field. So, divergence of a vector field is a scalar field. The divergence is generally denoted by div. The divergence of a vector field can be calculated by taking the scalar product of the vector operator applied to a vector field. So, it is completely a mathematical calculation where we try to measure the magnitudes. So, we can measure the field in 2 dimensions using the mathematical function application, that is, we apply the mathematical intervention into the laws and properties of divergence, and we formulate a situation where the real time scenario can be converted into mathematical equations. So, the divergence of a vector field can be extended to 3 dimensions. From 2 dimension structure, we can extend the divergence of a vector field to 3 dimension even. So, and again the process can be expanded and we can work more on 3-dimensional structures even.